1967. Inside a Soviet nuclear reactor compartment, a team of engineers is breaking through the biological shield. Concrete and steel. They are doing it with hammers. Nothing has exploded. A pipe is leaking somewhere behind that shield, and the people who designed it never planned for anyone needing to get back inside. Today, the ship those men were standing in is a museum. You can buy a ticket and walk through it. The tour does not mention this. In 1953, the Soviet Council of Ministers approved something no country had built, a nuclear-powered civilian ship. The target was the Northern Sea Route, the shipping lane across the top of Russia that stays frozen most of the year. Conventional icebreakers could work up there, but not for long. They burned oil, and they had to stop and refuel. A reactor doesn't. That was the whole idea, not speed, not size. The removal of the one constraint that had kept icebreakers on a leash since the invention of the icebreaker. She was built at the Admiralty shipyard in Leningrad, 16,000 tons, 134 meters long, 27.5 wide. 3 pressurized water reactors, 90 megawatts of heat each, driving 44,000 shaft horsepower through 3 propellers. A crew of 243. Inside the center reactor sat 219 fuel channels. Remember that number. The interior was, for the Soviet Union in 1959, close to unimaginable. A medical unit with its own operating theater and X-ray machine, air conditioning. It was a working ship, and it was also a room the state intended to show people. On the 3rd of December 1959, the flag was raised, and the Soviet Union announced that the icebreaker Lenin had entered service. Then she sailed to Kronstadt, to be finished. A radiation safety specialist named Yuri Smirnov had joined the crew the year before, at 19, the youngest officer aboard. 60 years later, living abroad, he wrote down what that day actually was. Not a commissioning, a performance staged on a schedule for a ship that was not ready. His line about it is the shortest description anyone has written of the entire project. The important thing was to crow. Dawn could wait. The Lenin was a machine, and it was also an argument. The first nuclear vessel the Americans built was a submarine. So was the first British one. The first Soviet one carried scientists, cargo convoys, and journalists. That contrast was the entire point, and Moscow used it hard. The 2 men responsible for the reactor plant presented a technical paper on the ship at the United Nations Conference on the Peaceful Uses of Atomic Energy in Geneva. Foreign delegations were brought aboard. The wardroom exists, on the museum tour today, as the room where famous guests were received. In July 1959, one of those delegations was American. Vice President Richard Nixon was in the Soviet Union, the same trip as the kitchen debate, and he arranged to see the icebreaker. He did not go alone. He brought Admiral Hyman Rickover, the man who built the American nuclear navy, and the single person on Earth most capable of understanding what he was looking at. We know exactly why he was there because the paperwork survives. A declassified American briefing memorandum, dated the 22nd of July 1959, puts it in one sentence. An important matter would be his opportunity to see the icebreaker Lenin. For this purpose, he is taking Admiral Rickover along. Smirnov watched the preparation from the other side. He describes the night before, the pier cleared, the ship scrubbed, everything arranged for visitors who would be aboard for roughly an hour. And then the most qualified nuclear engineer in the United States Navy asked to see the reactors. The reactors that were the reason he had crossed an ocean. They would not let him in. The New York Times reported that Rickover had been given the runaround. The restrictions were eventually lifted. He saw what he came to see, and he went home and gave Congress a report that a Soviet official, quoted in a second declassified cable, described as most complimentary. the showpiece of the peaceful atom, had something to hide from its own star guest. Within 6 years, it would have considerably more. By 1965, the Lenin had been running for 6 years on 2 fuel loads. The first from 59 to 62, the second from 63 onward. That second load was approaching the end of its life, and the ship went in for a scheduled refueling. The procedure is not complicated. Shut the reactor down, remove the spent fuel, then drain the cooling water. On reactor number 2, the last 2 steps happened in the wrong order. The water came out while the fuel was still inside. Spent nuclear fuel does not stop generating heat when a reactor is switched off. It generates less, but it keeps generating, for years, and it needs something to carry that heat away. With the water gone, there was nothing. The core overheated. Fuel assemblies melted, deformed, and fused in place. When the crew came to unload the core, they recovered 94 of the 219 fuel channels. The remaining 125 would not move. Some had broken into 2 pieces. 95 of the recovered assemblies were transferred to a support ship moored nearby, a vessel called the Leipzig, which would go on to spend the next 50 years as a separate nuclear problem in its own right. Smirnov, who worked on refueling operations on these ships for 4 decades, described that job in one line: the most responsible work, the most labor-intensive work, and in terms of radiation dose, the most expensive work there is. So who was hurt? The Soviet Union never published a casualty figure, not a number of deaths, not a dose, not a name. What is documented is this: dozens of sailors received high radiation doses, and they were required to sign non-disclosure agreements. Beyond that, the record is empty. There is a number that circulates: 30 men fatally irradiated. It appears even in the reporting of the environmental organization that has done more work on this ship than anyone, and every time it appears, it carries the same 3 words attached to it. It is said. Nobody who was aboard has ever confirmed it. The captain who commanded the Lenin through what happened next lived until 2001. He spent his last decade campaigning to save the ship from the scrapyard. He gave interviews. He is quoted in Russian on the subject of ice, of navigation, of the vessel's future. On this, he left nothing. The damaged core was removed, but the ship was not finished with. Fresh fuel was loaded into the reactors. And then a pipe in the 3rd cooling circuit began to leak. The leak was somewhere behind the reactor's biological shield, the concrete and steel barrier that keeps radiation away from the rest of the vessel. The shield was not designed to be opened. There was no hatch, no access panel, no procedure. So they broke it, with hammers. It worked, in the narrow sense that they found the leak. It also destroyed the installation permanently. All 3 reactors, the entire plant, now beyond repair. The decision that followed was not to remove the reactors. It was to remove the section of the ship that contained them. The fuel came first. The core barrel from reactor number 2, with those 125 stuck fuel channels still inside it, and all 5 thermal shields, was lifted out as a single object and lowered into a container. 2 concentric steel cylinders with a layer of concrete 550 millimeters thick between them. The gaps filled with a hardening compound, hermetically sealed, and then stored on land for 2 years. In September 1967, the Icebreaker and a pontoon carrying that container were towed to Tsivolka Fjord on the east coast of Novaya Zemlya. Divers cut through the lower hull by hand, underwater. Shaped charges took the remaining bulkheads. The reactor compartment, roughly 3,500 tons of it, dropped through the bottom of the ship as she pulled away. Two objects went into that fjord, about a kilometer apart, in 50 meters of water. The compartment, holding 3 reactors and their primary loop piping, came in at around 50,000 curies, mostly cobalt-60. The fuel container was the serious one. 100,000 curies, 3.7 petabecquerels. Roughly half of it cesium-137, roughly half of it strontium-90, and about 2,000 curies of plutonium, americium, and curium. Between 1965 and 1981, the Soviet Union dumped 7 marine reactors containing spent fuel into these seas, along with more than 6,000 containers of solid radioactive waste. When international inspectors reassembled that inventory decades later and recalculated it, they found that one single object accounted for 47% of everything still radioactive down there. It was the container from the Lenin. The ship was repaired. 2 new reactors went in at a yard in Severodvinsk. She went back to the Arctic and worked another 19 years. Thousands of ships escorted, hundreds of thousands of miles. A high-latitude passage north of Novaya Zemlya that no surface vessel had made before. She was retired in 1989, her hull worn thin by 3 decades of ice. None of it changed what was lying on the floor of the Kara Sea. She was saved from the scrapyard by her second captain, who spent his retirement arguing that she should be kept. In 2009, she was moored permanently at Murmansk and open to the public. On the day she opened, Russian state television reported that the icebreaker Lenin had never had an accident. Bellona publicly called that a lie the same week. The operator's official history of the ship, published online, does mention 1967. It describes it as a planned modernization of the reactor plant. The museum's own text goes a little further and refers to a series of incidents that made further operation of the reactors impossible. No dates, no numbers, no hammers. Smirnov, incidentally, was blacklisted for 6 years in the 1960s, denounced for sitting with foreigners in a restaurant, growing a beard, and studying English. That was the working climate on the ship the state was showing to the world. As for the fjord, a joint Russian-Norwegian survey estimated that around 800 kilograms of nuclear fuel remains inside the dumped assembly, and found no evidence that anything has leaked out of it. Sediment sampling at the site itself has come back at background levels. There is one measurement nobody has explained. A peer-reviewed study recorded tritium in the surface water of the Novaya Zemlya basin at 228 tritium units, against an Arctic background of 10 to 15. About 100 miles south of the dump site. The authors could not determine whether it came from the Lenin's reactors or from a submarine reactor lying nearby. Access to the fjord has been restricted, on and off, by the Russian Ministry of Defense. Russia has committed to raising 2 dumped submarines by 2030 at a cost in the hundreds of millions. There is no plan to raise this. The ship is still in Murmansk, warm, clean, open 6 days a week, with the reading room and the operating theatre and the cinema exactly where they were. And the part of her that mattered most is 50 meters down in the Kara Sea, sealed in a steel cylinder wrapped in half a meter of concrete, where somebody put it in 1967, and nobody has looked at it closely since.